People have been wondering what existed before the Big Bang for ages. This is a question that challenges our knowledge and messes with our heads. Imagine standing at the very beginning, staring at nothing, and pondering what existed prior to the Big Bang that created our universe. Time, space, and everything else began at that moment. However, was there anything prior to that? Was that all there was? Or, as we delve into this science, was there something else that we can't even fathom? This question takes us on an imaginative journey through theories that make us reevaluate everything. A physicist with extensive knowledge of the universe, Brian Cox, believes that something truly bizarre existed prior to the Big Bang. He wants us to rethink what we believe about reality, time, and space. We're going to explore the science, the ideas, and the strange mysteries that might tell us what happened before. Everything else will touch on cosmic inflation, quantum phenomena, dark energy, and even the multiverse. What we discover may surprise you and even alter your perspective on our place in the vast cosmos. Prepare to be scared into an unimaginable place filled with wonder and fear. Let's examine what might have existed prior to the Big Bang, and why. These ideas challenge everything we thought was true. To understand what could have been there before the Big Bang, we must comprehend the nature of the Big Bang itself. Scientists say it was the moment when the universe was super hot and dense and then quickly expanded, creating all the matter, energy, and forces we know. Galaxies moving away from a central point are evidence of this hot start, visible when we look at the stars at night. But why did it happen? And was there anything before this hot, dense beginning? Cosmological inflation asserts that there was a past that was not empty. Cosmic inflation says that before the Big Bang, the universe was cold, empty, and vast, like a giant void. However, this void wasn't truly empty. It held a tremendous amount of energy that caused space to expand at unimaginable speeds. This process, called inflation, happened so quickly that it set the stage for everything that followed. Space expanded at crazy speeds until it slowed down, and the energy transformed into matter particles and the forces we know today, the Big Bang as we understand it. But what was this energy? Why did it suddenly make the universe inflate? And why did it stop? Scientists believe that cosmic inflation created distinct regions of the universe, each with its own Big Bang. Each area represents a universe, including ours. This idea is called the inflationary multiverse, and it suggests there could be many Big Bangs and many universes. Our universe is just one of them. This vast concept challenges our understanding of existence and makes us wonder what else might be out there. The idea of nothingness before the Big Bang remains theoretical. Even if you took away all energy, particles, and light from the universe, it still wouldn't be completely empty. Dark energy, quantum fields, dark matter, and other forces persist, capable of producing something even in the emptiest state. This confuses scientists and suggests that true nothingness may not be possible in our universe. When we dig deeper, we see that space itself contains phenomena that prevent it from being truly empty. Imagine trying to create a place with absolutely nothing in it. No particles, no light, no energy. Yet quantum fields and fundamental constants would still be there. This implies that even in nothingness, there would still be something. One such thing is the lowest energy level of quantum fields, zero-point energy. In this state, particles can appear and disappear quickly, leaving behind a ghostly trace of activity, even in empty space. This contradicts our concept of a true void and shows that even before the Big Bang, something might have existed that scientists are only beginning to grasp. If inflation created our universe, it could still be ongoing. Brian Cox depicts a terrifying inflationary multiverse in which new universes are constantly expanding. Imagine that each Big Bang begins a new universe, and inflation continues in other regions, creating more. This may go on forever. This idea of infinite universes leads to a compelling thought, a fractal universe where each new universe can trigger its own Big Bang. Each universe is its own isolated world, unaffected by the others due to the rapid expansion of space. Scientists are both excited and uneasy about this idea. It suggests a multiverse with no true beginning or end. If quantum field theory is accurate, our concept of nothingness becomes even more complicated. What if our universe is just a tiny part of a larger cosmic structure that's constantly growing? According to this theory, the universe isn't just matter floating in space, it's a web of energy fields spanning the cosmos and interacting to produce everything we observe. Even in a vacuum state, when fields are at their lowest energy levels, particles can still appear and vanish, temporarily borrowing energy. These virtual particles create a ripple of activity that challenges the idea of a true void. Imagine a completely empty universe, no matter, no light, no energy. Would that be nothing? According to quantum field theory, no. Even in such a vacuum, fields remain active, occasionally producing particles. The universe does not follow our definition of emptiness. These continuous field activities suggest a cosmos filled with invisible energy, preventing complete stillness. This makes us ask, if fields create particles, and particles create matter, could quantum fields, dark energy, or some unknown force driving the universe's expansion have originated from this nothingness? Could dark energy have existed before the Big Bang? Some scientists believe that the dark energy we observe today may be a remnant of an energy field that existed before our universe. Dark energy's properties hint at a hidden force that may have influenced the birth of the cosmos. Some theories propose that a stronger form of dark energy could have driven the inflationary phase, enabling rapid expansion. The presence of dark energy means that even in a universe devoid of matter or light, this force would still be stretching the fabric of space. This leads to a haunting idea. If dark energy existed before the Big Bang, it might have shaped the very conditions that allowed our universe to form. Could dark energy be the silent driver behind cosmic inflation or even the beginning itself? We now face the possibility that dark energy not only holds the key to understanding the multiverse but may also have played a crucial role in the creation of our universe. Another fascinating theory is cyclic cosmology, which proposes that the Big Bang wasn't the beginning. In this model, the universe goes through endless cycles of birth, death, and rebirth. The Big Bang is not a one-time event but part of a cosmic rhythm where universes expand, contract, and regenerate. According to this theory, our universe may have formed from the remnants of a previous one. The cyclical process means there was never a singular beginning, just an eternal sequence of evolving universes. Cyclic cosmology raises profound questions about time itself, suggesting that time may be circular rather than linear. If this is true, it implies that the universe before the Big Bang was simply an earlier version of our own, collapsing to give rise to what we now see. This framework offers a way for scientists to trace the origins. Some ideas suggest they might have. If we could detect gravitational waves that predate the Big Bang, they could hold clues about a previous universe, or even about the mechanism that triggered the Big Bang itself. These waves might be imprinted on the cosmic microwave background, the afterglow of the Big Bang, subtly influencing its structure in ways we are only beginning to recognize. If so, they could act as messengers from a time before time, offering us a glimpse into an era where our physics no longer applies. However, detecting such waves is incredibly challenging. The universe has changed so much since its birth that any signal from before the Big Bang would be faint and difficult to distinguish from cosmic noise. Yet, scientists are developing increasingly sensitive instruments, like the Laser Interferometer Space Antenna, LISA, and upgraded versions of LIGO, that might one day help us capture these elusive ripples in spacetime. Then there's the even more radical idea: the universe we live in might be the product of a black hole in another universe. Some physicists suggest that black holes could create new universes in their cores, a concept known as black hole cosmology. In this framework, every black hole could be a gateway to a new cosmos, and our own universe might have originated inside such a singularity in a parent universe. This theory proposes a self-replicating multiverse, where new universes are continually spawned through black holes. The physical constants in each universe could be slightly different, depending on the conditions of their birth. Over time, universes capable of producing black holes would be more likely to create offspring universes, leading to a kind of cosmic natural selection. If this is true, it completely changes our understanding of reality. It means our universe is part of a grand lineage, descended from others, and perhaps giving birth to new ones through its own black holes. In this light, the Big Bang is not the beginning, but a transition, a moment of genesis in an eternal web of cosmic evolution. Ultimately, we may never fully understand what came before the Big Bang. Time itself might not have existed, making the question meaningless in traditional terms. Or it could be that our tools and theories are still too primitive to grasp the true origins of reality. But what we can say is that science is pushing us closer to the edge of the unknown. Each new discovery, whether in particle physics, cosmology, or gravitational astronomy, expands the horizon of human knowledge and brings us nearer to answering the oldest questions of all: where did we come from? And what, if anything, came before? Perhaps, one day, we will look beyond the Big Bang not with imagination alone, but with evidence in hand. Until then, we remain explorers in a cosmos filled with mysteries, forever chasing the echoes of creation. It's possible that gravitational waves existed prior to the Big Bang, providing us with a window into the universe. In the end, We know that one of the greatest mysteries in science is still what existed before the Big Bang. As new information and theories are discovered, the search for answers will likely continue for many years. Could the universe have existed continuously, originated from a quantum phenomenon, been the result of a cosmic accident, or something even stranger? Or, if we keep looking, could it have existed before anything we can comprehend, before time and space even mattered? The search for answers will undoubtedly evolve how we consider our future existence for ages. Folks have been scratching their heads, wondering what was around before the Big Bang. This is a question that really distorts our understanding of the universe and pushes the boundaries of what we think we know. Imagine being at the very beginning of everything, gazing out into nothing, and asking, what was here before the Big Bang? This is where time, space, and everything are supposed to have started. However, prior to that, there was either nothing at all or something extremely bizarre. Theories that boggle our minds date all the way back to before the universe was created. Brian Cox, the physicist who is into cool stuff about space, thinks there might have been something pretty strange going on. He wants us to rethink what we know about reality, time, and space. We're looking into the theories, guesses, and head-scratching mysteries that may reveal what happened before everything. We'll in this material check on ideas like cosmic inflation, quantum stuff, dark energy, and even the possibility of many universes. The answers might shock you as we try to get our heads around what might have been here before the Big Bang. We were the first to learn about the Big Bang. According to scientists, this was the time when the universe was extremely hot and tightly packed, and then it exploded outward, generating the energy and forces that we have today. Galaxies can be seen zooming away from one another in the night sky, appearing to be leftovers from this enormous explosion. According to cosmic inflation, the universe existed before the Big Bang and was cold and empty, spreading out like a huge nothingness. However, even this empty space had a lot of energy, causing space to expand extremely quickly. Space expanded like crazy and then slowed down. The energy turned into matter, particles, and the forces we know as the Big Bang. Why did it stop? Some scientists think this inflation created loads of different areas, each having its own Big Bang. Think of a huge fabric with bubbles popping up all over the place. A universe like ours exists in each bubble. So, there might be endless Big Bangs and never-ending universes. Our universe is just one of many. It alters our comprehension of everything. However, even if you eliminated all the energy and other things, it would still not be completely empty. There's dark matter, dark energy, those quantum field things, and other forces that are stuck. Even if all of that were taken away, the universe would still produce new forms of energy, perplexing scientists and raising the possibility that there is no such thing as absolute nothingness. Space has rules and restrictions that prevent it from being completely empty. Imagine attempting to construct an empty space. These quantum fields still stay. This indicates that even nothing possesses information. One of these things is the lowest energy state of quantum fields, zero-point energy. Even in empty space, particles can briefly appear and vanish, leaving behind a trace. Therefore, it was not a genuine void. Another crazy idea is eternal inflation. If inflation created our universe, then perhaps it is still ongoing. Brian Cox has this scary idea where universes keep getting made and stretching out all the time. Each Big Bang is like a spark making a new universe, while inflation keeps making others. It could go on forever and ever. According to this fractal universe idea, each new universe could have its own Big Bang. According to quantum field theory, there is more to the universe than just floating objects. It's a web of energy fields that make everything we see. These fields continue to function even when they are at their lowest. Particles can appear and disappear, borrowing energy for a split second. This makes virtual particles temporary things that pop in and out of existence. Imagine a universe devoid of anything. You would not have total nothingness, ever. In a vacuum, fields would still be active, sometimes making fleeting particles. This raises the question of whether the universe originated from this quantum field-filled nothingness. Dark energy is this mysterious force that's causing our universe to expand faster and faster. Is it possible that dark energy existed prior to the Big Bang? It's possible that this force existed before the Big Bang in some form. It might have powered the inflation. If dark energy existed before the Big Bang, it might have made the conditions that caused our universe. Is dark energy the cause of cosmic inflation, or even the true origin of our universe? Could dark energy reveal multiverse secrets? Another idea is cyclic cosmology. The universe is going through an endless cycle of birth and death. The Big Bang isn't a one-off thing. It's part of a cosmic rhythm where universes expand, shrink, and then re-expand. Our universe might have come from the leftovers of a previous one. Universes that emerge, change, and reappear never had a real beginning. Gravitational waves are ripples in space produced by major cosmic events, and what existed prior to the Big Bang may have been just another version of the universe that collapsed. Primordial waves could reveal specifics about the universe's beginnings. However, what if waves existed prior to the Big Bang? Gravitational waves could have existed prior to the Big Bang, according to some hypotheses, a time before the present-day universe. The search for answers to the question of what existed prior to the Big Bang will continue for years as new concepts and ideas emerge. Could the universe have always been here? Was it a cosmic accident, a quantum phenomenon, or something else entirely? As we search through the universe, the quest will shape our understanding of what is, to generations. As we probe deeper into the origins of the cosmos, new technologies and scientific advancements continue to push the boundaries of what we can observe and measure. The James Webb Space Telescope, gravitational wave detectors like LIGO and Virgo, and future instruments planned for deep space exploration may eventually capture signals from the earliest epochs of existence, perhaps even remnants from before the Big Bang. Some researchers suggest that imprints from a pre-Big Bang universe could be hidden in the cosmic microwave background radiation, the faint afterglow of the Big Bang. These anomalies, if verified, could hint at collisions with other universes or patterns left behind by a universe that existed before ours. Others look to the realm of string theory and loop quantum gravity for clues. These frameworks attempt to reconcile general relativity and quantum mechanics, possibly offering a model in which the Big Bang was not a beginning, but a bounce, an event where a prior universe collapsed and then rebounded into expansion. This Big Bounce theory suggests a cyclical nature to time itself. And yet, every answer seems to breed more questions. What if the concept of before the Big Bang is meaningless because time itself was born with the universe? What if our minds, evolved to think in terms of cause and effect, beginnings and endings, simply cannot grasp a reality where such constructs don't apply? Philosophers, too, weigh in on this mystery. If there was nothing, no matter, no space, no time, how could something arise? Is the universe a necessary existence, something that had to be, or an inexplicable fluke? Was there a creator, a consciousness, or an underlying law that transcends time itself? As we journey through these cosmic riddles, we are reminded that the pursuit of knowledge isn't only about reaching definitive answers. It's about the curiosity that drives us, the wonder that fuels discovery, and the humility to accept the vastness of what we do not yet understand. In this endless quest, the search for what came before the Big Bang is more than a scientific endeavor, it is a reflection of humanity's deepest need, to know where we came from, so we might better understand who we are.